Welcome to Using Subclasses. In this lecture, we take a look at a variety of things, and these things include the rules of inheritance, how to actually inherit, the super keyword, and finally with the super keyword, using the super keyword with constructors. So the first thing we look at is inheritance rules. And we know what inheritance is, what it does. We know all about the father-son relationship, but what we don't know is what are the rules for inheriting. There are some restrictions. As of right now, you know basically that the superclass passes on all of the methods and variables to the subclass. However, there are a few exceptions to that. So first of all, the first exception is that the constructors are not inherited. So remember, a constructor is basically a method in any class that enables you to create an object of that class. And constructors are an especially important part of every class, and it's important to note that they are not inherited. And because they are not inherited, that means that in the subclass you will have to create your own constructor particularly for that subclass. Now, there's also another important thing, which is overriding is possible. And basically what that means is, let's say you have a class and it's named vehicle, and this vehicle class is your superclass. And let's say one of the methods in that vehicle class is driving at 10 miles per hour. Now let's say that you have a subclass car, okay? And this car subclass inherits variables and methods from this vehicle superclass. So then, based on that, the car subclass will also inherit the method driving. However, there is a specific thing with the car subclass. In the car subclass, the car objects are supposed to drive at 20 miles per hour, not at 10 miles per hour. And because that's the case, we'll need to override the method, which means basically we'll need to replace the existing method so that it's specific for whatever class we're using. And this can basically be done by, as we've looked at earlier, we use the same declaration. So let's say that we have a declaration for for the method drive, which is public void drive, and that declaration is present in the vehicle class. Now, when we inherit this public void drive method into our car class, all we need to do is we need to restate it and put in the new code. And what this will do is this will override the existing method, and it will enable us to run the code that we need to run specific for that subclass. So overriding is possible. We can also add in new methods and variables. So the entire point of inheriting is that let's say when we inherit the vehicle methods and variables, we want to get everything the methods and variables that the vehicles have, but we can also add on more to it. So let's think of the vehicle class or the superclass as the general class. It has all the general information. But the subclass, or in this case the car class, has all of the specific information. It has a lot more details. So if it has a lot more details and characteristics, you'll need to add on more methods and variables. And that's something you definitely can do and probably will be end up doing most of the times you inherit something from a superclass. Now, one important thing to note is you cannot access the private methods and variables in a superclass. They're inherited, but you cannot directly access them. That means you cannot directly invoke a method, or you cannot directly modify a variable. However, there are indirect ways to do this through our setter and getter methods. And as we look at an example in this lecture, we'll be able to see how exactly that works. So we've been talking so much about inheritance, the rules for inheritance, how inheritance works. I think it's finally time to understand how exactly do you inherit. So you inherit using the extends keyword. So let's say we have a superclass, public class vehicle. This is the class declaration. So we have public class vehicle, and this is for our superclass. Now let's say that we have a subclass, and that subclass is called car. So we have public class car. Now, in order for us to indicate that we are inheriting, or there's an inheritance relationship between the vehicle and the car, we need to say public class car extends vehicle. So extends is the keyword here, and the extends keyword lets the computer know that you are inheriting inheriting the methods and variables of the vehicle class to the car class. So this extends keyword is very important, and remember, this extends keyword fits in right into the class declaration. Now please remember that the private methods and private variables are not inherited. So that's something very, very important to remember, and that's a mistake that programmers often make. So again, just to recap, we use the extends keyword in the class declaration. So we say public class, whatever the subclass's name is, extends whatever the superclass's name is. So now let's take a look at the super keyword and understand exactly how it fits in. So the super keyword fits in when you are partially overriding. And this basically means that you're adding on to an existing method. So let's say that we have a superclass, and one of the methods in the superclass is public void calctax. And then it has some code after it, which I've not displayed, but that's the important thing. So we have a method public void calctax. So now if I want to and I'm in the subclass, I've inherited this method in. Now in the subclass, I would if I wanted to, let's say I want to override this method. If I want to override this method, I'll in my subclass, I'll say public void calctax. And after that, I'll put in some new code which will override or have higher priority than the superclass method. And therefore, whatever code I type into the method in the subclass is the code that will be run. So that's how we override. But let's say that I already want to use, let's say I want to use whatever is in the superclass method, but I want to add on more to it. Let's say that I like what's in the method of the superclass, the calctax method in the superclass, but I want to add on more functionality to this method in the subclass. So then what I would do is, in the first line of this method, of the calctax method in the subclass, I would say super.calctax. And basically what this does is, this invokes the superclass method. And this invokes the superclass method, so that means that when we say super.calctax, the calctax method in the superclass is run. So what this does is, this basically enables you to invoke a method from a superclass, and then after you run, after that first line super.calctax, you can add on more statements and more functionality. So at the end of the day, the method in the subclass will be doing what the method in the superclass does with extended functionality. So this is an example of partial overriding, because we're taking an existing function, we're keeping it, and then we're adding a little bit more onto it. And that's what partial overriding is. And that's where the super keyword really comes in, because the super keyword basically enables us to invoke the method from the superclass. And you can tell it helps you invoke the method from the superclass because it's super.calctax. So that should help you remember that the super stands for superclass. And then after that, you can have more statements. And one important rule for the super keyword is that it needs to be present in the first line of a method. So as you can see, after public void calctax, which was a declaration, in the first line of the body of the method, super.calctax needs to be present. So whenever this method is run, the first line of that method that should be run is the super keyword line. That's something that's very important. Otherwise, your program will not function. Okay, so next let's take a look at the super keyword with constructors. So as you can recall from the inheritance rules, we know that constructors are not inherited. And there are occasionally situations where you actually want to use a constructor from a superclass. Now, the solution to that is to use the super keyword. So as you know, the super keyword is what enables us to run a method or anything, invoke a method from the superclass. So now let's see how we can do that. So let's say again that we have a superclass named vehicle. And inside this superclass named vehicle, we have a constructor for it, which is public vehicle. So that's our constructor for the superclass vehicle. And now let's say that we have a subclass car, and we have a subclass car. So the subclass car inherits all the methods and variables, but it does not inherit the constructor. So then in the subclass car, we're going to have to create our own constructor, and that constructor will be public car. So now let's say in this public car constructor, we actually want to use the superclass constructor, or we want to use whatever the constructor is in our superclass or the vehicle class. And what we're going to do is we only need one line for that. And the only line we need for that is super semicolon. And basically what this is doing now is this automatically invokes the constructor of the superclass. We don't need to put super dot method name because it automatically invokes whatever the constructor is for this specific, for the whatever the constructor is for the superclass. And this enables us, this basically is a workaround around when because the constructors are not inherited, but you can still use the constructors in a subclass using the super keyword. So the super keyword is something that's often used in inheritance, and it's actually used a lot in your programs because inheritance becomes a very, very important part of Java as you get into more advanced Java programming. So now let's move to Dr. Java, where we can see some code live and see exactly how inheritance is implemented. Okay, so here we are at Dr. Java, and I have two different files open. The first file I have open is bicycle.java, and the second file I have open is mountainbike.java. The first file contains the bicycle class, and the second file contains the mountain bike class. Now, the bicycle class in this case is the superclass, and the mountain bike class is the subclass, or the class that inherits all the methods and the variables of the bicycle class. So what we're going to do with this is we're going to walk through both files, and we're going to see exactly how both of them work, what goes on in the background, and see exactly how we've implemented inheritance so that when you're trying to use inheritance in your programs, you understand exactly how to do it. So please, as we move to the second file, keep a lookout for the two keywords extends and super, and see how inheritance makes our life a lot easier. So let's start off by taking a look at the superclass so we know exactly what's going to be inherited into the subclass. So our superclass is the bicycle class. So here we go. We have a declaration for the superclass right here. There we go. We've declared the superclass, and here's our first lines of code for our superclass. And those lines of code are private int gear and private int speed. So what do we know? We know that they're private instance variables that are of integer type, and they represent the gear and they represent the speed. So now let's move to the next line, and that is public bicycle. So because the method name is bicycle, and bicycle is the same as the class name, we know that this method is a constructor method. And notice how this constructor method does not take in any parameters, 0 parameters taken in. And basically what the constructor method does is whenever we create a bicycle object, it'll automatically invoke one of these constructors, and in this case, if this constructor is invoked, it'll say gear equals 0, speed equals 0. So it'll automatically give the gear and the speed private integer instance variables a value of 0. Now let's take a look at the next method. The next method is also a constructor because it has the exact same name as the class name. The only difference between this constructor and the constructor we previously looked at is that this constructor has two parameters. The two parameters are int start gear and int start speed. These two parameters are whatever the user gives us or whatever is given when the method is invoked, and whatever these numbers come out to be are what the gear and the speed variables will be set to. So in this case, whatever start gear comes out to be as an argument, we say gear is equal to whatever that value is, and then we also say that speed is equal to start speed, or whatever value is given when the method is invoked. So now we've taken a look at two constructors, one that automatically initializes our instance variables to 0, and another that gives our instance variables a value depending on whatever is given as the value. Now let's take a look at some of the getter and setter methods. So the first method we'll be looking at is public int getGear. So there's a couple of things that you can notice just from the name itself. Now, first of all, notice that this method is public, which means that the subclass can access it or any other class can access it. It returns an integer, and its name is getGear. So you probably know that it's an accessor method or a getter method. And it just simply what it does is it returns gear, which is our private integer instance variable. Let's take a look at the next. Method. The next method is public void set gear, and it takes in a parameter of int g. So as again, you can probably tell from the name that set gear will help us set the value of the gear private instance variable. And this is also known as a mutator or setter method. And all it does is basically it takes an integer. It takes an integer and it basically assigns the gear to that value, whatever that integer's value may be. Next, let's look at the next method. So the next method is public int get speed. So just like the public int get gear method right over here, we have the public int get speed method. It does the exact same thing, but in this case, it returns the speed rather than the gear. Now we have the public void set speed method. And this does the exact same thing as the public void set gear method. But in this case, it sets the value of the speed to whatever s is. So now we've looked at our getter and setter methods, which are also known as our accessor and mutator methods. Now let's look at some custom methods that will help us speed up and slow down our bicycle. So the first method we take a look at is the public void slow down. The public void slow down method. So as you know, this is a public method. It does not return anything. Its name is slow down, and it takes in a parameter of int decrement. So basically, you can probably tell whenever the method is invoked, whatever's in between the parentheses tells us how much the speed should decrease by. So the only line of code within this method is speed minus equals decrement. So basically, speed equals speed minus decrement. We're simply decreasing the value of speed by whatever the decrement is. And similarly with the speed up method, it simply tells us how much to increase our speed by. So speed plus equals increment, which is basically speed equals speed plus increment. So these are all the methods we've looked at. Now notice how all of the methods over here are all public. And then we have two instance variables, gear and speed, which are private integer instance variables. Now remember, whenever we have a private method or a private variable, it cannot be, even if the superclass is inherited, these private variables and methods are not directly accessible by the subclass. So now that we've understood the superclass, looked at its methods and variables, let's move to the subclass where we can look at how exactly inheritance works. Okay, so here we are at the subclass, and the first thing that you may notice is that it's a lot smaller. Even though the mountain bike actually has more information and more things to it, it's actually much smaller than the bicycle class. And the reason for this is inheritance. Right there and then, before we even look at this program, you can see how useful inheritance is, because now we don't even have to write as much code, and all of the code in the bicycle class is being reused in the mountain bike class or the subclass. So the first line, and this is the declaration, which is public class mountain bike extends bicycle. So again, we're declaring the method, and there you see the extends keyword. The extends keyword, this tells the computer that we are inheriting the bicycle class. This tells the computer that mountain bike is the subclass and bicycle is the superclass. So now what happens with just those two words, extends bicycle, just adding those two words on, the methods and the variables of the bicycle class are automatically inherited into this mountain bike class. So now let's take a look at what's inside of this mountain bike class. The first thing we see is private int seat height. Now you may be thinking, as we know, we've inherited the bicycle class. And because we've inherited the bicycle class, we know that it should be showing different variables and methods that we've inherited. But the thing to know is that even though we've inherited them, they don't have to show up in our program. We know that we have access to them, and we know that the mountain bike contains and can do all of these different perform all of these different methods, but they don't necessarily have to be here because the computer already knows. Because by using the extends keyword with bicycle, the computer already knows that we have access to and have inherited the methods and the variables of the bicycle class. So as you can see, what we're doing here is we're going private int seat height. Now this is not something that you saw in the bicycle class. And the reason you didn't see it in the bicycle class is because it's specifically for the mountain bike class. So this is what usually happens in inheritance. With the bicycle class, we got all of its methods and variables. Now we add on to what we add on things to this inherited bicycle class, such as seat height, that enable us to create the mountain bike class. And that's what inheritance is all about. The subclass takes what the superclass already has and adds on more things. So basically you're building on top of a block and saving yourself time. So we already know that the mountain bike class has private int gear and private int speed. So now the only instance variable that needs to be added on in this case is the private int seat height. And the reason we're adding it on again is because this is not part of the bicycle class. Next, now we have our constructors. So as you remember, the constructors are not inherited, so we have to create our own constructor. And here we have public mountain bike. So within this public mountain bike constructor, we have super. And if you recall from earlier in this lecture, we remember that when we use the super keyword, we can access methods from the super class. So let's say that, for example, when I just say super, that automatically invokes the constructor of this super class. So this line right here, this line super, all it does is it goes to the bicycle superclass and invokes its constructor. So when the computer sees this first line, the computer automatically goes to the bicycle class and runs this first method. And what this method does here is it sets gear and speed to 0. So what happens then the computer executes this line, gear and speed are set to 0. So remember, gear and speed are instance variables of mountain bike. You don't see them, but they are part of it because of inheritance. So now gear and speed are automatically set to 0. And then we set seat height to 0 because remember, seat height is not part of the bicycle class. Seat height was introduced in the mountain bike class. So we need to give seat height a value of 0 in order for the computer to know what its value is. Gear and speed automatically get a value of 0 because the bicycle constructor is run using the super keyword. So we've looked at the first constructor, which gives gear, speed, and seat height, those three variables, a value of 0. Next, let's look at a constructor that takes in 3 parameters. So we have public mountain bike, and then it takes 3 parameters: int start gear, int start speed, and int start height. So as you can probably tell from the parameter names, we know that the values given when this method is invoked will enable us to set the values of the gear, speed, and height instance variables. So the first line in this again is super start gear start speed. Now in this case there are 2 arguments with the method. So we know that we're executing a constructor, but we're executing a constructor with 2 arguments. So now what the computer does is when it sees these 2 arguments, the computer goes back to the bicycle class and it looks for a constructor with 2 arguments, and it finds its constructor right here. So now then what this constructor does, as we went over earlier, is it gives gear and speed a specific height. So that's exactly what happens when this first line is executed using the super keyword. The start gear, whatever start gear is based on this, and whatever start speed is based on this, become the values of their respective instance variables. So gear is equal to start gear and speed is equal to start speed. And again, we've saved ourselves a lot of time and space, because rather than having to type out all of the code, we've used the super keyword to automatically invoke something from the super class. And then we give seat height a value of start height. And this simply, remember that start height is not part of the bicycle class, so we need to give seat height a value of start height. And that's our constructor using 3 parameters. Now again, notice that the super keyword, whenever it's used, it is part of the first line of the body of whatever method it's in. And that's a rule that you must abide by. Now, you may be thinking that what if instead of using this super keyword, I wanted to say something like gear equals start gear. Now, the problem with this is, even if you wanted to do that, you couldn't do that. And the reasoning for that is that, remember that this gear instance variable is private. This gear instance variable is private in the superclass. which means that this subclass mountain bike does not have direct access to this gear variable. So that wouldn't even work. We have to use the super method in order to get this change. Now let's say that we're not using our constructor and we still want to give a value to gear or speed, and we don't have direct access to them. Well, that's where these methods come in. That's where the the set gear and the set speed methods come in, or these mutator or setter methods. What these methods do is, these methods are public, so we can access these methods, and using these methods we can set values for the gear, the gear. So for example, I could say something like set gear, and then I could put start gear right here. And what this would do is, this would automatically give the gear instance variable a value of start gear. Now, the super keyword is a lot more convenient to use, but that's another option. So now you can really see why we have the setter and getter methods, because often there's situations where the subclass cannot directly access some of the private instance variables, and that's where you want to use these getter and setter methods, so external classes that may be inheriting them or relate or using these methods can still modify the value without directly accessing these private instance variables. So we have the super keyword right here. We use seat height equals start height, and there's our 3-parameter constructor. Now to cap this off, we have the getter and the setter methods, which, as you can probably tell by now, are a classic part of all of these classes, because remember, this seat height is private, so that whenever any program wants to modify the value of this seat height, it'll need to use these methods in order to do so. It cannot directly access the methods of these. So we have the get and set height methods, which we're very used to because we've already seen such getter and setter methods before, and we just saw them in the bicycle.java program, where we saw get gear, get speed, set speed. So again, we do the exact same thing over here. So getter and setter methods are a custom part of this. Now that we've looked at both programs, we can see that look at how much easier it is to create the mountain bike program. Imagine having to declare all these variables again. Imagine having to create the getter and setter methods for all of these different variables, and imagine having to use the slow down and the speed up methods and write them all again. That's where inheritance comes in play. My life was so much easier while creating this program, and that's how your life will become much easier when creating Java programs. So to recap, we use the super and the extended keywords in order to indicate inheritance and use methods from the superclass. And we saw exactly how inheritance works and exactly how we can access private things, how we can use constructors from superclasses, and overall we were able to see why inheritance is so useful.